Alright, welcome back everybody. In this lesson we're going to look at how we find complete graphs of functions. We're going to find all of the important information that we've learned how to find in one particular problem using all the tools that we've used thus far this year pretty much. We're going to identify all of these characteristics and then use them to create what we call a complete graph of the function. So we're looking for the roots, we're looking for the y-intercept, we're looking for any maxima and minima. We're looking for any intervals of increasing and intervals of decreasing. We're looking for the points of inflection. We're looking for where it's concave up and concave down. We're looking for any vertical asymptotes or discontinuities. And we're looking for any horizontal asymptotes and the end behavior of the function. And there's a brief little recap of how we find all of those things over here that you can, kind of follow along with as you do these, or, however you choose to use it. In this video, we're going to handle example 1. We're going to draw a complete graph of this polynomial function y equals 2x to the third plus 9x squared minus 24x plus 13. So the first thing I'm going to do is I'm going to find the roots of this function. And in order to find the roots, I'm going to set the original function equal to 0, and I'm going to solve for x. Now this is a cubic function, so it should have either 3 roots or 1 root. I'm going to use my calculator to help me find this. Normally we would do this with an easier function to work with, and we would be able to do all of the things that we're doing here, by hand, in essence. But it's a little cumbersome to solve for the roots of this by hand, so I'm going to use my technology to help me out. Start off looking in a standard window. There's one of the roots, and we see over here that there might be a second root, and there might not. Looks like at 1. So I'm going to go ahead and find the zeros. I'm going to go all the way over to, let's go to -8. That's on the left of that first root. And -4 is on the right of it. Uh-oh. Maybe -8 wasn't to the left of it. No sign change. Let's try this again. Maybe I just had the values too far out. Alright, and so we get one root here at -6.5. So we've got -6.5 comma 0 as one of our roots. And the other root here looks like it's at 1. Alright, and so we have our roots. And by the way, if I substitute 1 back into the original function, I get 0. So there we go. There are our roots. First thing off my list. Then the y-intercept, which we're going to get by substituting 0 in for x. We substitute 0 in for x in the original function. The y-intercept is 0, 13. Alright, now to find the maxima, minima, and the intervals of increasing, decreasing, we need the first derivative. To find the points of inflection and the concavity, we need the second derivative. So I'm going to go ahead and find the first derivative and the second derivative of the function right now. Y prime is 6x squared plus 18x minus 24. And y double prime is 12x plus 18. Yep. Okay. So to find my points of inflection and intervals of concavity, I'm going to set this equal to 0. And I get x equals oops, my brain got a little bit ahead of my hands there. Set this equal to 0, and we get that x is equal to negative 1.5. And so we're going to have a point of inflection at negative 1.5, comma, whatever the y-coordinate is at negative 1.5. That's 62.5. So we have a point of inflection there. And we can get our intervals of concavity as well here. It is going to be concave. Well, let's make a sign chart for the second derivative. And it's positive to the right and negative to the left. So it's concave up on the interval from negative 1.5 to infinity. It's concave down on the interval from negative infinity to negative 1.5. And then I'm going to go for my extreme values. I set y prime equal to 0. Need to make sure that I keep all of my important information highlighted here. Alright, so then I need y prime equals 0. If I divide all that by 6, this factors as x plus 4 times x minus 1. And so we have extreme values at 1, comma something, and negative 4, comma something. By the way, we already found the y-coordinate at 1 up here. So we've got a maxima or a minima there. And now we need to put negative 4 into the function to get the y-coordinate of that value. That's 125. Alright, now my sign chart for my first derivative. And so I substitute values into the first derivative and find from my sign chart that those are the intervals. Therefore, I have a max at negative 4 and a min at x equals 1. Because of the sign change in my sign chart from positive to negative indicates a max, and negative to positive indicates a min. And then my intervals of increasing, I can read from this sign chart, negative infinity to negative 4, and 1 to infinity. And decreasing from negative 4 to 1. Alright. Almost finished. We have two last things to check out, the potential for vertical asymptotes and the horizontal asymptotes end behavior. So we have a vertical asymptotes, we have none, because polynomial functions are always continuous. So we have none. And as far as horizontal asymptotes go, we'll take the limit as x goes to infinity of f of x, and the limit as x goes to negative infinity of f of x. I got to bop back to the previous page to look at my function here. And when I bop back there and look at my function, I see that the limit as x goes to infinity is going to go to positive infinity, which means that as I go to the right, the graph's going to keep going up. And as I go to negative infinity, the limit goes to negative infinity. And so the ends of my graph should go up and to the right, down and to the left. And so as far as horizontal asymptotes, there are none. Okay, now I have all the information that I'm going to use to produce a graph. I have a little graph grid down here. and I'm going to put all of that information on the graph grid. Now my scale is going to be a little bit different for my y values and my x values. I need my graph to go all the way up to 125 in the y direction. So I'm going to mark my axis off by 25s. And to catch all the pertinent information as far as x values, I need to go all the way out to at least negative 6.5. So let's go out here to negative 8. And positive 8. Okay, and now I can graph the points that I have that are important. I've got negative 6.50 as a root. I've got 1, 0 as a root and also as a minimum. I've got 0, 13 as the y-intercept. So that's going to be right in here. And all I'm doing is plotting all the points that we found in the previous section. I've got negative 4, 125. And then let's see, what else? What am I missing? Oh, my point of inflection at negative 1.5, 62.5. And now do I have all the points plotted? Roots, y-intercept, point of inflection, minimum, maximum. Okay. Now, the graph is concave down from negative infinity to negative 1.5. And it's increasing through this root. It's concave down all the way over to here. And then it's concave up the rest of the way. And it's decreasing until it gets to 1. And then it starts to increase. And I have my right end behavior and my left end behavior correct. And so there is a reasonable sketch of the complete graph of y equals 2x to the third plus 9x squared minus 24x plus 13. Alright, so a lot of information to find and a lot to do in one of these problems. But if we go through it methodically and just use all the things we've learned so far, it's not a terribly difficult task to complete. Alright, that's the end of this video. See you guys next time. We'll look at example 2 in the next video.